All right, so in the previous two videos for section 6.1, I've told you how to identify if a function is one-to-one graphically, how to identify if a function is one-to-one analytically. The whole reason that we care about a one-to-one function is this. If a function's one-to-one, when I find what's called the inverse of the function, then the inverse will also be a function. So functions all around. So what does it mean to find the inverse? Very simple. The inverse is just what you get when you flip the x and the y value. Okay, so we're going to flip the x and the y values. Ran out of space there. So let me do better. You guys deserve better. Values. Okay, we're going to flip the x and the y values. So first examples, here's just a couple of functions that are one-to-one. Notice no x's, no y's are repeated in either of these sets of ordered pairs. You might want to pause the video and write these two things down. Now that you're back from writing them down, here's how you find the inverse. The inverse is notated by a little -1. Okay, so this is f. This is f inverse, f with a -1. That's not an exponent, that's just the notation for the inverse. And the inverse just means I'm going to go through the ordered pairs and I'm going to flip-flop all of the x's and y's. So instead of -3, 2, I'm going to have 2, -3. Instead of 5, 6, I'm going to have 6, 5. Instead of 8, 7, I'm going to have 7, 8. And then instead of -9, 12, I'm going to have 12 and -9. That's my inverse. The same thing for g. When I find the inverse of this function, it's just a matter of flipping all the x's and y's. Notice this is one-to-one. No x values repeat, no y values repeat. So I'll flip-flop everything. 3, -4, 7, -1. And then 8, 0. And though that's my inverse. Now, going over to my graphing board, here's what I would like you to do. Pause the video, grab a piece of graph paper, and I would like you to graph the function x cubed plus 4. Now, I'm going to do it right now, and I'm going to write our points, and what we're going to do together after you've graphed it is we're going to then graph the inverse by simply flipping the x and the y values. So my x cubed plus 4 means I'm moving my x cubed graph up 4 units. So I take my 0, 0, and I go up 4. I take my 1, 1, and it goes 1, 5. I take my 2, 8, and it becomes 2, and 2, 4, lost count, 2, 4, 6, 8, 10, 12. And we go up 12. So this is the point 2, 12. This is the point 1, 5. This is the point 0, 4. And then instead of -1, when I go up 4, it becomes -1, 3. And then last but not least, -2 instead of -8 is going to be -2 and -4. So here are my points. Here's my cubic function. Whee! Okay, so now what we're going to do is we are going to graph the inverse of this. And all that means is I'm going to take each x value and y value, I'm going to flip them and have new points. So instead of the point 2 and 12, when I flip the x value and the y value, it's going to be 12 and 2. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oops, didn't think that through, did I? And then 11, 12. So it's going to be somewhere right about here on my door. So we'll just remember that. Instead of 1, 5, it's going to be 1, 2, 3, 4, 5, 1. Instead of 0, 4, it's going to be 1, 2, 3, 4, 0. Instead of -1, 3, it's going to be 1, 2, 3, -1. And instead of -2, -4, it's going to be -4, 1, 2, 3, 4, and then -2. So taking into account the point that's on my door up here, when I go and connect these dots, I get a graph that looks something like this. That's my inverse. So instead of f, I have f inverse of x. Now, there's one interesting relationship that I'd like you to see here. Some of the homework problems in the book will ask you to finish a graph based on this property right here. Notice there is a line of symmetry here. It might not be apparent at first. Hopefully this helps. But notice that if I make the line y equals x, okay, so this line right here, 1, 1, 2, 2, 3, 3, 4, 4, and if I draw this dotted line right here, and then draw it backwards, This is the line y equals x. A graph and its inverse will always be symmetric along the line y equals x. Notice I have the same thing. If I folded this graph along that dotted line, I have the same thing above the line y equals x as below y equals x. All graphs and their inverses will have that property.